We are all familiar with the visible spectrum of light, but sometimes forget that there are other wavelengths of energy that we can't see. There are gamma rays, X-rays, ultraviolet rays, our visible spectrum, microwaves, radio waves, and of course, infrared energy. Not all infrared energy is equal, and the medium wave infrared is the type most readily absorbed by food products and animal proteins. These waves occur at the 3 to 4 micron range, and importantly, are emitted when an object is around 850 degrees Fahrenheit. Where do we get infrared energy? We're familiar with a variety of infrared sources, though we may not often think about them. The sun, for instance, gives off nearly half of its energy in the infrared spectrum. A simple campfire can produce up to 25% of its energy in the form of infrared waves, and more so from charcoal and embers used for cooking the world over, the rest of its heat being in the form of hot convective air. The advent of ceramic infrared burner technology allowed for efficient simulation of these glowing embers and produces up to 35% of its energy in the infrared spectrum, with the remaining 65% transferred through hot air convection. This is accomplished by the unique construction of these burners, with thousands of evenly distributed holes that result in a corresponding number of tiny flames, which heat the ceramic to temperatures over 1,000 degrees Fahrenheit, causing it to glow red and emit infrared energy. The common feature to all of these infrared emitters is that they glow. You can see the light they give off, and for the purposes of cooking, this is wasted energy. Infrared waves are invisible. The most efficient infrared cooking appliances generate emissions without also generating light. For example, cast iron or plain carbon steel with a properly prepared surface will give off 100% infrared energy when heated to the appropriate temperature. This is the premise on which the VTech infrared charboiler is based, a heavy gauge carbon steel plate heated to a uniform temperature of 850 degrees Fahrenheit.